Right, so this steamroller is probably what we are doing. So what we are trying to do is to smooth a time series. So trying to take out all the bumpiness or the waves that we can see in the data. So we are going to do that at some extent, and that is why we have here this picture in there. So just as a recap, so all time series have level. Yes, it's always present. The level is simply the average. Yes, the average of the time series, and they also have a trend, so direction if you want, and a steady increase or a decrease over time or nothing. They always have as well a seasonality. Yes, the seasonality is a pattern that repeats itself every season. So here we can see in the picture that we have actually a seasonality around here. Yes, yes. So for instance, in sales, microeconomics, or for sectors, we have that we have a season usually in December and in summer. So are different type of seasonalities in there. Yes, so there is a reason why we have seasonalities. And finally, we have something called the random error, or the reminder, or simply the error. Yes, which is something that we cannot forecast. It doesn't has any direction. The noise is like the old TVs in which you were able to see dots, so there is not possible to recognize any pattern. So in the reality, the noise is something like that. Although sometimes we have techniques in which we use the errors to try to extract even more information from the errors. But the idea is that we want to extract all the information from the errors up until there is nothing in there. Yes? Right. We have here a moving averages. So here we have like um, an exchange rates. Yes, I do not remember what is this. Here it says is USD JPY, which is dollar against Japanese yen. Right, so exactly the same. We want to smooth this time series. So these are bars. It's a graph of bars, and what we are doing with smoothing is trying to smooth these waves in order to understand more the patterns of this exchange rate. Right, so that's all. That is what we are doing here. So the main idea is to forecast future points by using an average of several past points. Yes, so that is actually what we are doing. I think the main idea, all these main ideas of these methods are probably one of the most important things that you need to remember. Yes, rather than the mathematics, rather than the details. Yes, so the first assessment, probably you will use a lot of presentations. You will be using the details about Refinitiv and this and that. And I will explain the second assessment later on in this course. So what are the uses? Time series visualization. We did an exercise in my previous video. And also computing seasonal indexes. Yes, so and forecasting. Yes, so what we want to do is to try to calculate what are those sessions, and possibly to calculate an index for those sessions. Yes, and also to predict what is going to happen. The advantages of moving averages is that are simple, popular, easy to understand, and also they make our life actually very easy, because it takes out like a lot of fluctuation in the data that sometimes creates a lot of noise, and decreases the ability of techniques to predict. So a key concept here for the moving average is the width of the window that relates to the number of observations that we are using for the moving average. So for the coronavirus exercise, I recall we use 7-day deaths, yes, in order to calculate the moving average. So that 7 days are actually the width of the window, yes, the width of window. That is the concept of moving average and with windows. All right, so we have here two types of windows. Yes, we have a center moving average. In the reality, we are not going to use a center moving average. Center moving average will be simply, as we are calculating an average from these observations, is to center the average in between the data. Yes, which will have a lot of sense. In finance, what we do is the opposite, to like lean the average to the end, yes, like in this fashion. So we calculate the average of all days, and we do not center the data, although it has probably a lot of logic to center the data, right? Yeah, obviously, if you can center the data, if you are not obviously using exponential average, like giving weights to the old or recent information or observations. So so in order to compute a trailing moving average, yes, a trailing moving average is an average that uh, goes forward or rolls forward and carries calculating itself. We need to choose the window W. Yes, I think that is something that you will need to use. For us, it's very simple. Economists, we want to like a smooth data or time series. So generally, the window W relates to something like 7 days, 12 months, 4 quarters, and so on and so forth. Or 1 day if you have the data in hours, or if you have high frequency data that is less than a day, right? Number two, for moving average at time t, place window on time point. So we have a t minus w plus 1 up until t, right? So this w, for instance, if the window is 7 days or 7 months, t minus w will be t minus 7 plus 1, yes, it will be t minus 6, right? Up and t minus 6, time t minus 5, t minus 4, t minus 3, t minus 2, t minus 1, t, that will be 7 observations in the fashion we have in here. So let's imagine that the window is 5, yes. Um, Imagine that we are calculating 5 days in a week. So the first one will be t minus w, that is t minus 4, because if the window is 5 minus 1 is 4, right? Oh, plus 1, yes. The next one is t minus 3, t minus 2, t minus 1, and t. These are 5 observations, and we calculate the average with these times. The third step is to compute the average of values in the window. So that is what we do, compute the average of this window equal to 5. So the moving average, what it's going to do is to simply say that with letters, right? So the moving average in time t equals y in times t minus w plus 1. I recall this, yes, that allow us to calculate these numbers, right? And depending on the window, so this is going to be the t minus 4, t minus 3, t minus 2, etc. up until t, yes? And this is divided by w. So as t increases, therefore this moving average is going as well to increase in time, and that is going to be a trailing moving average. Here I have an example using the real average weekly earnings. So the first black, very black, dark line is a center moving average. There are not many really, or many like uses in finance for this. Well, there might be something about generating strategies for show using a center moving averages. In general, what we are going to do is to lean to the right the average. So, and we will use that last observation as a forecast. So, how to forecast with moving averages? So, to forecast a series at time t plus k, use a trailing moving average that ends at time t. So, I think we already covered this in the previous step, yes. Why we have t minus w plus 1, we already covered that in the previous slides. The only thing that we are changing here is that we have ft plus k, which is the forecast. Obviously, it's not just t, it's plus k because k is the number of periods that we want to forecast. Yes, so f in t plus k equal gt minus w plus 1, gt minus w plus 2, etc. It's exactly the same, right? Yes, so as you can see, there are not many differences between that equation and this equation here. Is very the same. Yes, it starts exactly with the same numbers and it finishes exactly with the same figures here. The use of k is obviously to forecast afterwards. This means that the very last moving average is going to be the forecast in time t plus k. So if it is t plus 12, you are going to see a straight line after the last forecast. And that is what we are seeing here, yes? So we are not able to forecast more, and therefore we have something like this, yes, in a straight line. This is when we have, or when we are calculating everything like out of the sample. There is a way in which we can calculate a forecast, which is in red, using moving averages, but rolling the window to the right. Here this graph is interesting because, as you can see, the partition is in this red line. This partition differentiates the training period, which is all this section, and the validation period. This is my first forecast, and this red line is my second forecast. The black line is the actual values. So as you can see, obviously this red line is going to be more accurate, yes, more close to the actual values, because it's using roll forward forecasting, meaning that every time that the time is passing, the validation period is getting smaller and smaller and smaller, and the training period is increasing. Yes, so therefore the latest forecast is more accurate, more precise. So that is why the red line is a beta forecast, and this allows me to say that out of the sample forecasting can actually not be compared with this roll forward forecasting for obvious reason. This red line is taking into account the previous information that is being added after each calculation of the forecast. Here we have another example of Amtrak ridership, which is a train with W equal 12, the window equal 12. Here the data I think is in days, so this is going to be a 12 days possibly. Oh no, this is in months, so this is 12 months, right? And the validation equal last 3 years. Meaning that we are going to make a partition in the last 3 years. Again, here we have the partition of the data in green, yes. This data here is the validation period, The data to the left is the training period. So we are able to calculate a forecast. This one looks like it's a roll forecasting, and after forecasting this, we are able to get to know what are the errors. So the residuals are the difference between the actual value and the red line, which is the forecast, and this is what we have here in terms of errors. Yes. Furthermore, if we want to extract more information from the errors, it's still possible if we are attempting, for instance, to calculate these seasons that are appearing here, or in case that we do not have data that appears to be noise, or that means that it does not have information. So here we have measures of accuracy. We covered them previously. They are very important because it allows us to choose forecasting techniques. Yes, so for this we are going to have these indicators of accuracy for both the training period and the validation period. So if we fit the values in the training period, we are able to calculate this. And also, if we compare the forecasted red line with the actual values, we are able to calculate the errors. So this MAPE is simply the moving average percentual error. Yes, and we have other type of errors here, other type of indicators that we covered during the previous session. What we do is actually to compare both of them. We can see that actually in the validation period the errors are closer to zero. Yes, they are consistently lower than in the previous one. Yes, the only one which who differs is this last indicator. The other two are by way less than the validation period. Right. So we do not compare the errors in the training period and the validation period. What we do is to compare the errors of measures of validation periods between different types of forecasting techniques in order to select what is the most accurate one. Okay, that is the theoretical part. Thank you very much. Life is not passing me by, it's trying to run me over. All right, okay. So I will see you in my next video, in which we are going to cover very quickly in R code using the graphs that you just saw here on the theoretical part. Thank you very much.